We will give you the entire roadmap, and we are going to do this course in 6 months
In software engineering, first thing I want to do is programming.
which will make you become a ML engineer or data scientist.
In machine learning, there are three foundational pillars according to me: business, math, software engineering.
Sir, course will be industry oriented, making you ML engineer or data scientist.
First project will be COVID-19 impact on Airbnb demand.
Any visualization tools are used?
The language of a data scientist is visualization.
You are going to teach GitHub as well, right?
Market basket analysis is the inputs. If you see one of the list of options, these are the similar to what you can see.
So we will go in depth with the transformers.
I will be introducing transformers.
Will you take any case study to explain?
Something is simple machine learning use case.
Hi guys. So we are bringing up a course which will make you become ML engineer or data scientist, and we will give you the entire roadmap. And we are going to do this course in 6 months for free on YouTube. And Harsha sir is going to do this. You already know Harsha sir. If you don't know, the link is in the description about introduction to Harsha sir. You can just go through that video. And now Harsha sir will explain what are the topics he is going to discuss, and also why he is going to discuss those topics, what is the relevance, especially the industrial relevance. Okay, in GATE we are going to talk about mathematics in detail, and it is exam oriented, research oriented, but sir's course will be industry oriented, making you ML engineer or data scientist. Okay, so let's hear from sir what he is going to teach. Yes sir.
Sure, sir. So, in machine learning, there are three foundational pillars according to me: business, math, and software engineering. Right. So, let's look at each of them in a little more detail. Let's take first part: software engineering. In software engineering, the first thing I want to do is programming.
Okay.
That is foundational. So, in programming, also I want to go into depth into Python. So,
Okay.
Python fundamentals. Then I want to do data structures, algorithms, dictionaries, lists, sets, these kinds of things, stacks and queues. And then I want to do object-oriented programming, and then error handling. How do you handle errors if they occur? NumPy, pandas, Git, and version control.
Any visualization tools are you going to use?
I will take visualization a bit later.
Okay.
So this is core Python.
Mhm.
After doing this Python course, I want to have two case studies or two implementations.
You mean to say projects, kind of
Projects.
mini
Two.
projects. Yeah.
Yeah, after doing this Python course, I want to do two mini projects. First mini project is deploying a simple Flask application. I want every student to have a deployed Flask application by the end of this course. Right? Second project is scheduling a pipeline using GitHub Actions. So there are in the industry, these are the
So sorry to interrupt you. You are going to teach GitHub as well, right?
I'm going to teach GitHub also at an overall level. And I'm going to use GitHub Actions specifically to implement any kind of scheduling events. So I want to schedule some things. So some things that happen at a interval point of at a specific interval. These two are the use cases that I want to do for Python, simply for Python. Next, let us go to the business point. Right. So the second pillar, foundation, would be visualization. You asked about visualization. I don't want to put it in Python. I want to put it from a business in part of the business. Because the way businesses, the language of a data scientist is visualization to talk to the business. So here again, let's start from a little bit of coding point of view. I will look into Matplotlib, Seaborn, and Plotly. These are the three important packages for visualization in Python. And then I will talk about business storytelling with data. And then I will go into different plots like box plot, histogram, bar charts, mosaic plots, scatter plots, etc. And after that, I will go again back to ML based visualization, specifically what is univariate, bivariate analysis. How do you visualize to have an intuition about your ML models? That is more important for us, right? For a ML engineer, for a data scientist. Then I'll again do two projects. First project will be COVID-19 impact on Airbnb demand, and the second project will be visualization for an ML use case. So I will take a specific ML use case, I will build up the visualization for that, and then I will explain why this visualization is important, which features are important, which features are not important, this kind of intuition I want to bring it out at this stage from the visualization itself. The third pillar that I mentioned, math, statistics. I will start with statistics. In statistics, again, I will just start with descriptive statistics, sampling, probability, intuition, common distributions, central limit theorem, all these topics that are important. And then I will look at correlation versus causation. And in statistics also, I want to do two use cases. First thing is market basket analysis using associative mining. Market basket analysis is if I buy one product, let's say Netflix, right? If you see one movie, it gives you a list of options. These are the similar movies that you can see. Amazon, if you buy one item, it will give you a list of items.
Recommendation
System kind of thing, right? I want to build a simple market basket analysis using just the concepts that we learned so far, that is statistics alone, without going into complex ML models at this stage. Next, I want to model call center operations. Now, the reason I'm going into call center operations is because in whatever sector you are, you have to imagine what all distributions are there, how is your data, how does it interact with uh, how does it interact with the real world. So I want you to get an intuition of how the real world looks like, what are the distributions in the real world, and I want to use a call center as an example to give you that understanding. Right. Next, in math, I want to go into linear algebra. In linear algebra, I want to look at vectors and matrices, not from a math point of view, but from an intuition point of view. Right. After that, I want to look at matrix multiplication. After this, I want to do basically principal component analysis, which is a part of machine learning. Principal component analysis is used to, let's say you have 100 features, it is used to bring it down to 10 features. Right? If you have 100 features, what can you do to bring it down to 10 features? 10 features are easier to handle. 100 features have their own issues. I will talk about what are the issues, etc. later. Next, I will jump into embeddings. So in my GenAI video, I will explain what are embeddings. Embeddings are also nothing but, in many ways, they are nothing but vectors or matrices. So I will go into embeddings, I will go into similarity metrics, and I will do another case study. This is on customer survey analysis. So we will look at a customer survey, how to get results from a customer survey, how do you find patterns within a customer survey, right? Next, again, going back to software engineering, we'll go back to data management and SQL. Right, here we look at simple SQL fundamentals, joins, aggregations, window functions. Then we'll look at all these SQL related stuff. But then we'll jump quickly to Python, and in Python, how do you do all these things, right? And after that, we'll look at how do you handle imbalanced data sets. So a lot of data sets, especially in the classification problem, have one class will be 90%, 98%, another class will be 2%, 3%. So how do you handle this? We will look into that. We will look into different parts of feature engineering. Now, feature engineering, I put it here, but feature engineering is a constant topic that keeps going on. Even after machine learning is over, we will still be looking at feature engineering, different concepts, right? And I will be looking at mutually exclusive, collectively exhaustive, the concept of how do you create features and all of that in a little detail.
Will you take any case study to explain this?
Yes, there will be two case studies that I want to take. First thing is a simple machine learning use case that I'll be using later in machine learning course. I want to do cleaning for that data set. I want to do feature engineering for that data set. Right? Next is
which project is that, sir?
In machine learning, whichever project we take up, largely I'm thinking we will take up a mapper mining kind of project. Whatever project we take up, we'll do the cleaning part here. We'll do a little bit of cleaning, feature engineering, creating new features, how to think about the problem, all of that here. Next, I want to build features using CRISP DM methodology. So again, not just cleaning the data set, but also building the features, new features, whatever are relevant features for this data set. This will be a real world data set. This will be a real world example that I want to take, not some dummy data, right, for a machine learning use case. It will be the same use case for which we are going to build the data. We will go back to math. We will be doing hypothesis testing and experimentation next. And here we will look at null and alternate hypothesis. We'll look at different types of hypothesis tests like t-test, ANOVA, chi-square tests. We'll be looking at A/B testing frameworks, and not just these concepts from a mathematical point of view. We'll also look at different case studies. Here in hypothesis testing, I want to take 4 case studies. One is marketing, A/B testing in marketing. I want to take drug trials in pharma. How do drug trials work in the pharma industry? I want to do two case studies in retail. One is customer and another is demographic analysis. Okay, 4 case studies which will basically cover your 4 tests: t-test, ANOVA, chi-square, and the z-test. All these 4 tests in a way. Right. Next, once you have your foundations ready for all the 3 topics, that is business, math, and software, then I want to jump into regression and classification. This will be our first machine learning models, right? So we will look at our basic models, we will look at linear regression, logistic regression, we will look at decision trees, ensembles, we will look at support vector machines, KNN, naive-based models, all these models, right? We will not be looking at neural networks here, we'll look at neural networks at a later stage. For now, we will limit to these models, and then we'll look at model interpretability. It's not just that, okay, there is a model, how do you interpret this model? We will look at this, and we will look at some other concepts that are important from a business point of view, like from an implementation point of view, like data leakage, what are evaluation pitfalls, what are accuracy metrics, precision recall, AOC, ROC, RMSE, ME, R squared, all these accuracy metrics we'll go into. And how do you interpret a machine learning model, and what are the trade-offs of building each kind of model? What are the assumptions? What are the trade-offs? We will go through all of this in detail. Right? Here, I have 2 use cases that I want to do. First thing is a regression use case. I want to predict the house prices. Again, this will be a realistic data set where I want to predict the house price at a certain location and based on different features. And the second thing is I want to again use explainable models in healthcare domain, right? So, for example, predicting heart disease. So, these are models where you can't use unexplained models. You need to have explainability. Explainability is important. So, in this module itself, we will look at explainable models. Then we will jump into machine learning. Right? In machine learning, we will look at cross validation. We'll look at hyperparameter tuning, ensemble models, and test train validation strategies, etc. And then we will take 2 use cases again here. First thing is predicting risk in banking sector, and second thing is demand forecasting for a consumer goods manufacturer. Again, both the use cases will have real world data that we will be using to predict either risk. Risk is a classification problem, or demand forecasting, which is a regression problem. Then we will jump into time series forecasting. In time series forecasting, I want to look at trend, seasonality. I want to look at moving averages, exponential smoothing, and then ARIMA models, right? And then I want to do some feature-based forecasting. This is using your machine learning and your classification regression models to do forecasting, but having good enough features so that it becomes a time series model, right? And then evaluation metrics. And then we will take 3 case studies here. We will do a simple, just moving average based stock market trading strategy, not anything complex, just based on moving average. Next, we will be predicting air quality, and then that is in a way like predicting what is a PM25 particulate matter 25 in a location. That is very seasonal, so I want to take up that use case. Next thing is I want to do demand forecasting for a company like Walmart. So these are 3 use cases I want to do. Then I want to jump into deep learning. So the neural networks that we skipped then, we'll start it here. So in deep learning, I want to start with neural network basics. I want to go a little bit into backpropagation. I want to go a little bit into dense networks. Once these are done, I want to jump into RNN and LSTM, and then I want to go into autoencoder decoders. Right? I am not going into transformers. I'll do that in the GenAI module. So here I want to have one case study, that is aircraft engine failure prediction. And again, this will have simulated data that I'll be giving, and we will try to predict failure of an aircraft engine using deep learning models. After this, I'll go into optimization. So, optimization and operations research. Here, I want to go into linear and integer programming, constraints modeling, OR tools, etc. And again, two use cases here. One is supply chain based optimization. Second thing is shortest path and shortest and network flow problems. I mean, network flow shortest path problems. These are anyways standard in the industry. I want to also go through them. Next, I want to go through clustering and segmentation. Here, I will talk about k-means, hierarchical clustering, DB-scan clustering, and how do you evaluate a cluster. And I want to go to a case study where we want to cluster high delay zones in the Indian Railways. Okay. Again, this will be a real data set. This will be a data set that we will do web scraping and extract the data for the last whatever day, and then based on the last day's extracted data, I want to do clustering and find out zones where where in the Indian Railways where you have some kind of delays. Are there any specific zones like that? Right. Next, I'll go to GenAI. So till now it is all traditional ML and all of that. So now we're going to GenAI. I want to talk about ChatGPT, Gemini Cloud. I want to talk about different tokenization methods, embedding methods.
So will you go in depth with the transformers?
I will be introducing transformers, and I'll be introducing other algorithms that
So
are needed.
you will be explaining the paper, right? The popular paper.
Yes, I'll be going a little bit into depth into the popular paper on the transformers, Google paper, and I'll also go into attention. Right? Both these topics are important. And yeah, I'll be looking at tokenizations, embeddings. I'll be working on RAG pipelines, and hallucination vector databases, RAG evaluation. How do you evaluate a GenAI model, RAGs, LLM as a judge, etc. Again, I want every student to build their own RAG chatbot and deploy it. So every student should have two use cases deployed. First use case that we saw, Flask use case. Now the same Flask use case, we'll use it in the deployment, but later the second deployment is here. I want every student to deploy a RAG chatbot on their own website link, whatever link they want. Next, I'll be looking at local models. Local models, will be looking at Llama and other local models. Right. Next is agentic AI and orchestration. So we'll be looking at tool calling, memory, LangGraph, Clue AI, multi-agent workflow. And here I want to look at multiple use cases. Coding agent using GitHub Copilot, natural language to SQL, that's a SQL agent, visualization agent, a web scraping agent. I want to build a supervisor agent and an enterprise chatbot. So the difference between a RAG chatbot and enterprise chatbot, what is the difference, and we'll try to build an enterprise chatbot end to end. Now after all of this, I want to close it with deployment, MLOps, and evaluation. I will look at a Streamlit Flask. We looked at Flask deployment. I will relook at Flask deployment, but for machine learning models. So in the previous sections, we would have learned machine learning. I will relook at the same Flask deployment using Flask, and then I'll also look at Streamlit models. After this, I will just give a brief introduction to cloud-based deployment strategies for ML, like AWS, like Azure, like GCP, etc. We will look at how to handle model versioning, how to handle drift, how to look at bias in AI, and data privacy risks. Right. So as a capstone, I'll combine all these topics, and we will deploy one machine learning model using Flask or Streamlit that we learned in the first session. We are again integrating back in the last session. So we will combine all of this and deploy a full-fledged application either on the cloud or using Flask, or in some form. Different batches will be given different exercises to do, and this is what I want to do in the whole course. This is an end-to-end program which covers all the three pillars of data science and then goes at a reasonable depth into each one of them.
Thank you so much, sir. I think we'll be learning a lot from you. And students, this is a free course but not a cheap course. So try to make the best use of it. I know you are already busy with Gate and other your job and all, but if you can spend some time every day, you will be learning a lot, and you can easily transform your careers into data scientist or ML engineer. Okay, thank you so much.